So I'm Jorge Salamero. I work for FOSDEM. How many people know FOSDEM here? Oh, that's good. That's quite a few. So I'll show you some basic about FOSDEM. But today we are going to talk about something, it's like kind of an experiment, little project. It's called FOSDEM tracers. And we came up with this thing because traditionally sysadmins, they have been doing troubleshooting, not tracing, because sysadmins, they didn't used to do tracing with these kind of tools. Uptime free, well, you know all that. But then suddenly something changed, and these tools, they become less useful with Docker containers and all that. But then, in addition, we got microservices deployed everywhere, and it was time for a change. Developers started to use, because they had new needs, they started to use sort of different tools, and they started to use tracing heavily, because when you have distributed services, you need to know how they talk to each other, where are the problems, troubleshoot like in between. There are quite a few options, some of them open source, big ones compatible with open tracing, which is a standard API. A few commercial, probably you know, New Relic, AppDynamics, and obviously people, because they didn't have heavy and very specific needs, they just had to monitor something. They started to do all sort of hacks, like using StatC, JMX, prints. Who hasn't done prints to see what their code is doing? Or misusing logs for that. But we thought, what if we have something that was obviously open source, so everyone could use, that it was very simple and easy to use? Who knows, or who is using more or less often VCC here? Okay, no one. It's great. eBPF, it's a great tool, can do amazing things, way more than FOSDEM, but it's difficult to use. You need to know the API, you need to know every system call you want to hook into. It's complex. It has some trade-offs. Also, we wanted to have something very lightweight that could run everywhere inside containers. So we have the FOSDEM technology, and we thought we could do something else. Not to get confused, we have FOSDEM open source tool, and then there is another commercial tool that I'm not going to talk about it today. We'll focus on the open source. For those that didn't know how FOSDEM works, basically what we do is we instrument at the kernel level. We load a very small kernel module that allows us to capture every single system call and everything associated with it, and send it into a user space agent that can run as a daemon or inside a container, and even save it into a file and do all kind of analysis and everything. Some of you, probably this is going to be a question later on, so I'm going to answer already. Why we didn't do this with BPF? Well, when FOSDEM was created, BPF didn't exist. Even now, the way it works has been changing a lot lately. Who has kernel 4.11 deployed in their servers in production? That's what we need to do everything we do with FOSDEM, so that's why we have a different kernel. Hopefully that in the future changes, but this is how things are now. So at the end, FOSDEM, everything it does is capture system events that they are system calls. We filter them. We can apply all sort of filters and run scripts to reshape, aggregate them. We can dump things into a file. So at the end, it's like TCP dump for syscalls. We have container support, and we have a command line and courses interface. How things work internally is that we have like an event stream where all the system calls that are introduced, open, reads, connects, everything, every single call. And we dump them into a disk, something like pickup file. We filter them, we do some analysis. And with this, we thought that we could do some tagging on these events. So we created these sysdig tracers. This is like not distributed tracing. It's system call tracing, which we think it's enough for most of the cases. Obviously, we are not trying to compete with New Relic or full distributed application tracing. As I said before, we want something simple, lightweight, easy to use, that can work for like daily use. So the idea is to inject markers inside the sysdig event stream. These marks, they can basically scope, they mark anything. So we can mark function calls in our code, we can mark network requests, any piece of code. You can do this from any language. And when we started to design sysdig tracers, we thought about creating a virtual device in a /dev. But we wanted this to be container compatible. And we thought, well, dev null is always available everywhere. No matter how minimal is your container, it's going to be there. We can capture every single syscall, so why not use a dev null? It's a hack, but it works. And low overhead, like, as I said, simple, easy to use, fast. So the idea is that we have this event stream, and every time, always, we have like an entry marker and an exit marker. So a span is everything that's being executed inside. The enter trace and the exit trace. If you notice, like the symbol just before the trace, is useful to understand if it's an entry or an exit. This is the span. And we can obviously have like a tree of different spans and nested structure to measure different things. When we write to /dev/null, we can do it in two different ways. We can use a very simple format, so parsing it's not very complex, where we have a direction, an ID to identify the span, some tagging, and we also have arguments. So in case we want to have function entry arguments and function exit arguments. We can also use JSON format, but the other one is more simple. And I'm going to show you an example. When I was deciding what kind of title use to show you sysdig tracers, one of the examples I like to start with is this one. And it's, when I saw this, I thought, well, this is like APM for Bash. So let's call this APM for sysadmins. It's not entirely accurate, but I think it's a good an easy way to describe what sort of things we can do. So yeah, if this is a loop, there is an echo, which is a write, of that string into dev null. We use a tag, then we do whatever we want inside, which is load the page and then the exit. So when we run this, we are going to mark all the system calls happening in between, and we will be able to do things with them. What kind of things we can do? A few examples. Well, we can measure latencies. So in this case, in the example before, we can measure how long does it take to execute that command. We can save things to a file and analyze later on. We can open it with the nCourses app. We can see like what's happening inside, all the system calls that executed. We can see logs in case that was a daemon doing stuff, wrote or exported into stat.c, because we also misuse stat.c, and have it in our monitoring system. So that's everything I have on the slides, and now we have 15, 20 minutes, and I'm going to show you how this works live. So I'm going to take a seat because I don't know how to type properly, standing up, and let's move here. So I showed you before that, can you see this better now?
Which was the light?
Which one is the light?
This one here? These two.
Okay, yeah.
So now? No, he prefers these two.
Now,
But the thing is,
What black and white is better.
okay.
you need to turn that back on afterwards because it affects the...
And if you move your window a bit to your...
Let me see if I know how to change this. Okay, so that's the script I showed you before. I made some changes. That PP is to use as the ID, the parent process. So I got that one. I'm going to run it. Going to leave that behind, running. And I got another bash script here, which it's loading Google. Same thing, different tag. I'm going to run it as well. And I have those scripts that they are running or they are triggering traces. So now what I can do is to open SysDeck. This is my laptop. And for example, we have multiple views here. If you have used HTOP before, you will find this very similar. We have multiple views with different things. Keep that for a different talk because I don't want to go into all the details that SysDeck can do. I just want to focus on tracers. But one of the most nice views we got is histograms. So histograms allows you to see the latency. We are missing something. No, it's... There we go. No. So we can see the latency of the network. We can see that some pages, they go fast. Most of them, they are around 100 milliseconds. Some requests, they take longer. And I can do all sort of things like, and this is when I'm going to open the notes I have because
We see only half of the terminal.
so this is just for me. You can ignore it.
That's easy.
Okay, so for example, I mentioned before we had command line and courses interface. So the command line, there we go. If I say, okay, filter everything, actually I want to give you a second to have a look at this. Event type tracer, I want you to filter out all tracers. So I see this, the command, the ID, the different tags, and this is live happening. But SysDeck has a lot of filters, so I can do different things. So if, for example, if I want to see only the tracers from the script loading the SysDeck website, I can do event type tracer and then span.tags SysDeck. If you have used TCP DOM before, this is going to be very, very similar. The syntax is very intuitive. And now we are filtering only SysDeck. But probably I want to do more interesting things. I want to know how fast are we loading. So what I'm going to do is to format the SysDeck output and include a span duration. So I want to see how long does it take to execute everything I have inside. Okay, so this is around 200 milliseconds. Cool. I can write things into a file. Okay, so can you see this on the bottom? Or just dumping everything into a file. And then I can use the end courses interface. Something happened here. Okay. So I'm going to capture a few seconds of my scripts. That will be enough. And now I can open it. And I can show you the spectrogram that I showed you before. This is a very small sample, but I can do interesting things, saying, okay, so most of the requests, as I said before, they were around 100, but I'm wondering what was this. So I can click. And then I see that, well, for some reason, there was a request to Google that took 283 seconds. But we can do all the things, like, for example, I can say, okay, I want you to send all this into StatC. SysDisk has some scripts written in Lua that allows us to manipulate all the events, all the syscalls. So basically, everything it does is to take all the tracers, convert them into StatC, and I got here somewhere. We'll see if it works very quickly, otherwise you will have just to believe me. That we are exporting those latencies. No, my laptop is not connected. Well, you will have to believe me. This is basically exporting all the metrics into StatC. I want to show you more interesting things. So yeah, right into /dev/null. Still have a few more minutes. In addition to do things manually, we also have some libraries, some wrappers for different languages. This is for Python. We also have for Node.js. We also have for Go. You can use it in different ways. I can show you a more complex example later on. But this is, if we use this with a statement, we can tag all the code executed inside with this hello world and do things with it. So let me run this script. So you see there is one hello world from inside, another one from outside. But what I can do is going to minimize this, open. So I can say, okay, SysDisk, show me all the events, so all the system calls being executed inside that span. That was just a print of hello world. So if we just do one iteration, oh, there we go. So we can see it's a write to /dev/pts, and then the tracer exit and the data of the write system call. So this is very simple, but we can again use chisels to filter and format this into a nicer way. So I have the Echo FDS chisel that everything it does is to capture those system calls that they are writing into any file descriptor and echo them into an ASCII format. So hello world. I can only see hello world and know the hello world from outside. So this is a very simple example, but since we have, how long we have? Okay, I'm going to show you a more complex example. So I wrote here a Python web service that has 3 different endpoints. One is doing, it's calculating a Fibonacci number, just to demonstrate how we can use decorators to tag with sysdig tracers everything inside this function, including entry and exit arguments. Or, as we saw before, using the with statement to scope different pieces of code. And as I told you at the beginning of this talk, we can use a tree, a hierarchy of different tracers, and we can have some tracers inside of each other. So I'm going to run this. Let me remember how I was running this. Okay, looks good to me. Okay, so I'm going to run everything. Like I got the server, I show you, and I got the client, which is doing random requests to the different URLs. Both they are different microservices running in different containers, and we got sysdig running on the host, and we are going to be able to see what's happening. So I'm going to record a few seconds. Of all the tracers being executed, because it's more convenient to work on a file. Just a few seconds would be enough. And now, I'm going to cancel this, and now we can start working with that file. So, for example, I can do this filter that it's going to show me all the spans that took more than 5 seconds. So I can see like the different tags I showed you before. Download handler, Fibonacci, the different pieces of code that it was taking longer. If you can see here in between my scripts running on the background, they are showing from time to time. Very slow requests on the network. But we can do more interesting things. We can use, again, chisels, and we can group the different system calls that they were writing into any file descriptor and create a very simple report. So we know that the piece of code inside of do download write, it wrote 1 gig in file descriptors. We know that the download write wrote 500 megabytes. Obviously, headers did not write almost anything. Empty headers, the same. Fibonacci, we got less requests, etc. We can even see that Hello World is writing to, again, in the background, some other stuff. We could use filters. And for example, what I can do is say, okay, this is writing on any file descriptor. But what if I want to see only network traffic? Well, I can do file descriptor type and then IPv4. And I'm going to get exactly the same report, but only for sockets, IPv4 sockets. If I'm interested in seeing like file descriptors that they are actually files on my file system, I just use FD type file. But I can do even more fancy things. So I'm wondering, okay, so what kind of files are you writing on the file system? So I'm going to add some extra filters, FD type file, and then I want to see only the files written by that tracer, and I want to exclude my terminal because I'm not interested in anything being written on the standard output. So I'm going to run this, and I see that my code, that it's a black box. It's running inside of a container. Some developer created this, started to run it on my infrastructure, and I have no clue what it's doing. But now with sysdig and tracers, I didn't have to read the full code. I just went around different functions, and I were adding decorators and with statements. And okay, and now it's writing some files. And wait, one of them is quite big. So it's probably the one that's making my microservice to go more slow. We can use different chisels to format the output. So for example, if I use the HTTP log and I write it properly, I'm going to be able to see all the HTTP requests happening, like method, URL, response code, latency, size. Or I can use only show me the top URLs. So we can see that this was the URL that my random URL generator hit it more. There are plenty of different chisels. You can write your own, but we created the few that they are shipped by default. So I show you decoding HTTP requests. We can decode memcache requests as well. Writing one, for example, for Redis should be very simple. We can visualize things in spectrograms. We can show top CPU process, errors, activity on file descriptors, spine logs. If there is a daemon writing some logs and we don't know where they are being written, we will find it. Some network filters, performance, or security. Well, I think this is everything I wanted to show you today. I think we have around 10 minutes for questions. Questions, anyone? Yep.
You have this now. We need to like. Okay.
Hello. Okay. My question is, if I'm having this running on like a couple of systems that I want to trace, is there an option to parse this to something where I can filter it like in, I don't know, Kibana or something? Is there like a front end where I can just compare the traces of different machines to see events and stuff?
We wrote a front end to aggregate tracers coming from different microservices. It's a very, very experimental project. It's open source. It's available in our GitHub. Actually, I haven't linked it here, but if you go to github.com/Rios, browse between the repositories, and there is some JavaScript application that can load some JavaScript application and some Lua chisel that write things into a format that the Java application can load, and you can see the requests from different microservices. But it's something experimental. We created this, as you saw, it's small. It does quite a few fun and interesting things, but it's an open source, it's work in progress. We are still figuring out where this is going.
Okay. Another question is, what was it? I had it. Now it's gone. Yeah.
Okay, we have more time. You can grab me afterwards, otherwise. Yeah.
I wonder, for very large systems like those that have 10,000, maybe 100,000 of requests per second, is there any possibility to sample while recording, just recording 10% or 1% of all events?
What you can do is to filter everything you write on the capture file. So I don't know how big was my capture file, but you saw it was just a few seconds, and you see it's 100 megabytes. So imagine running this into a production system. We have customers that they trigger this and they get like gigabytes in just 1 or 2 seconds. And then you need to open that file and you need a powerful machine. So ideally, you want to apply capture filters so you reduce the amount of information that you are sending into a file. Use filters.
No, it's okay.
So you told that to install this, you are inserting like a kernel module. So how do I install it on like legacy stuff? Do I have to on a Red Hat 4 or 5 or something like this? Does that work, or does it just work with recent kernels?
The SysDig is packaged for the most popular distribution: Debian, Ubuntu, Fedora, Red Hat CentOS.
But also for old ones, like really old ones?
So I don't know what's the minimal kernel version that we require. We use DKMS, so we dynamically build your kernel module. So I don't know, I will have to check out.
Okay.
Give it a try.
Thank you.
I think you have some questions.
Nee, I think it is.
Okay.
That's okay.
When you're using Docker, for instance, can you filter to certain containers?
Can you repeat your question?
When you use, for instance, Docker, can you filter to just see the events for a certain container?
Yes. So I showed you this before, the different chisels. So for example, if we use that chisel, allows us to filter the different containers I have running. But actually, one of the things I haven't mentioned in this talk, and I'm talking about it later on another talk, Troubleshooting Kubernetes, is that the other cool thing that SysDig does is we talk to your orchestration tool API. In this case, Docker, but if you're running Kubernetes, OpenShift, Mesos, DCOS, we talk to it, to the API. We know what kind of infrastructure are you running, the pods, namespaces, services, and you can use that metadata in SysDig filters. So you can say, okay, give me the syscalls from this pod, or give me everything happening in this namespace. So, yeah. Another question here?
So I didn't get the main idea behind SysDig. So is it built on BPF? Because you said several times that it's similar to TCP dump, and we know that TCP dump was using BPF firstly. And second, just what about the overhead that SysDig just create? Or does it take a long time to do that, or it takes a lot of resources? I don't know.
Well, the project started like 5 years ago, something like that. One of the reasons not to use BPF is that BPF didn't exist as it is today by then. Has changed a lot. It exists, but in a different way. And we had requirements that they were not covered by eBPF or BPF by then. So for example, when we capture syscall, we want to see like everything, all the buffers, and for example, eBPF can only give you a small chunk. We have been submitting patches to the kernel, and now we are in a position that probably SysDig could start using eBPF. We haven't done it yet. We have to look at it properly. But yeah, the reason was that originally it wasn't possible. And this is like multiple years project. The team who created, or the person who started SysDig, Loris, he was one of the creators of Wireshark. So you will see a lot of similarities between TCP dump and Wireshark to SysDig. It's more or less the same concept, but instead of capturing and analyzing network packets, we do it with system calls and everything happening. Okay, well, if there are no other questions, I left some links. Please use all the stuff, like leave feedback if you found this talk interesting or you thought it was crap. Have a look, test these links, test the product. And as I said also before, I'm doing 2 other talks, one on SysDig applied to security on containers, and another one use for troubleshooting instead of tracing. So have a look at the schedule, and if you like it, you can join. Thank you.